Well, to everyone that's tuned in, good afternoon. You've all, by the sounds of it, been listening to us in our preparation, dealing with some of these technical problems. We've managed to overcome them, I'm pleased to say. So, welcome to this roundtable debate that we're hosting today at the BESA conference. My name's Adam Raymond. I'm the regional sales manager for the UK North and Ireland at SWEP International AB. Today, I'm very lucky to be joined by five distinguished panelists from across the HVAC industry. And we're going to discuss, we're going to debate, we're going to have a general chat about the subject of water quality in HVAC systems, more specifically closed loop water systems. We feel this is a good subject to talk about because the way that we heat our homes and businesses and places of work is undergoing a lot of change and will undergo a lot of change in the future. The decarbonisation of heat is top of the agenda. I mean, all the things that are happening at the moment, COP26, the heat in building strategy that came out recently. So it's a really important subject for the planet, for our country to reduce carbon emissions, to give ourselves, a sustainable future and that for our children as well. So, we hope it's going to be a good debate that you can all take away some important knowledge, some information, some insights from the six of us today. So this is our sustainable city. This is part of a presentation that we've done here at SWEP for other purposes, but I felt it really was quite relevant here because it illustrates how the sustainable city of the future could work. Of course, it could be that not all these different technologies are in the same place, but these are all the options that we have at the moment. So biomass, CHP, energy from waste, some of the more common ones where we've got renewables there, geothermal, which is more up and coming as well, waste heat from data centers. It's all here. One of the things, in fact, the main thing that all these technologies have in common is that they're using water and mixtures with different chemicals and different inhibitors and so on. But water is the primary carrier of the energy from these energy centers to where the heat is required in the sustainable city. So it goes to stand that the quality of this water that's going through these systems is of absolute critical importance for the efficiency of the system, to make sure that they're running well and indeed fulfilling the low carbon ambitions that they have, but also for longevity, for effectiveness as well. We don't want the end users having breakdowns, leaks, and so on. So it is, as one of our speakers said during the preparation for this event, it's the lifeblood of the system. So we think this is quite an important subject to talk about. Why is it then that heating systems are corroding? I'm sure all of us here will have stories that will come out during this debate, and some of you guys that are listening will have some stories or have heard stories about systems corroding. So why is that? Most new systems that are installed and designed today are sealed. So by the inherent nature of a sealed system, it's sealed off from the air. So that should already give it a good start. A lot of systems now, there's a myriad of chemicals on the market, corrosion inhibitors and so on, magnetic filtration. These have all come on in leaps and bounds, certainly from when I came into the industry 24 years ago. And we've also really updated the guidance and the standards from the various bodies, BISRIA, CIBSI, and so on. So, yeah, why is it that they're corroding? We're going to talk about that. We're going to have a good debate on that. Here at SWEP, we like to, we've almost been forced to sort of take a lead on the subject because as a manufacturer, we are the last port of call if there's any problems. So if there is an issue with corrosion or water quality, then we need to know why. Is it a product issue? Is it not as resilient as it should be? Or has it been something else to do with the installation that we can then advise the installers and the manufacturers of the equipment that we're supplying, you know, this is what you need to do. You've got these conditions that are going to affect our product and anything else made of that metal. So we try to provide some leadership and guidance in this area. I'm sure some of my colleagues have the same recommendations there from the panel. There's also very comprehensive guidance from our colleagues in Europe, in Northern Europe, so Germany, Denmark, Sweden, Switzerland, Austria, Netherlands and Belgium. They all have their own standards. I believe they're all aligned very similarly, but there's guidance that we're all now starting to look at. So we're going to talk about that a little bit more in the debate, so I'm not going to cover that too much here. So yeah, without further ado, I'm going to stop sharing this presentation, and there's some questions that I'm going to put forward to the guys, but before I do that, I'm going to introduce everyone. So in no particular order, we've got Antony Corbett from Geberit. Antony, do you want to say a few words?
Yep. So hello, everybody. My name's Antony, as just been alluded to. So I've been working with Geberit for 13 years, nearly 14 years now, as a technical engineer, but now my role is a product applications engineer. So I look after, per se, the supply systems that we manufacture. So as some of you might know, our products are manufactured in Germany. So the interest that I've got in today's roundtable is particularly to do with the perceptions around carbon steel, but also looking at all of our other supply systems as well. It's not just limited when we're talking about hydronic systems. We're not just limited to one type of material. And of course, that's something that we'll be talking about later today.
Great. Thanks, Antony. I'll go round in the order that I'm seeing the talking heads on my screen. So, Gordon.
Hi, Adam. Thanks very much for giving me the opportunity to speak today. My name's Gordon Pringle. I'm the Managing Director of HASL. We're a firm of specialist H&V distributors specialising in a limited range of equipment, but equipment that is very much focused in the closed system control, the marketplace, hence my representation today. And I just want to share our experiences within that sector, and in particular with a relatively new innovative device, which is providing great evidence into this sector effectively.
Thanks, Gordon. And Krista, my colleague.
Colleague to Adam from working at SWEP. I've been in a business about 20 years for a heat exchanger business. I'm business development in what we call district energy, which includes district heating, cooling, and so on.
Cheers, Krista. Christian?
Yeah, good afternoon, everybody. Christian Engelke is my name, working for Wiesmann in the UK as a technical director. And obviously my interest participating in the group, and thank you very much for inviting me, is to share not only our interest, but also making everybody aware of that heat generators, which is what Wiesmann is producing and manufacturing, are very critical in the heating systems, as these guys are actually suffering from any mistreatment of water systems. So I'm hoping to share some views about our philosophy of how heating systems should be treated from the water point of view.
Great, thanks, Christian. And finally, Chris Owen.
I'm Chris Owen. I'm a Customer Technical Services Manager at Tata Steel Tubes. I'm also a member of the BISA Pipework Working Group, and I'm also Technical Chair of the Tubes and Fittings Association. And whilst Tata is very heavily focused on carbon steel tubes, in my other roles, obviously, we're very interested in systems approach. So I'm very interested in understanding a lot more about mixed metal interactions within building services. And again, over the last sort of 14 years I've been in this industry, it's very noticeable that there's a lot of legacy issues as well as innovations which we can face as an industry which is obviously growing.
Great, thanks, Chris. So I'm going to go straight into the questions that we've got to pose to you guys. So the first one, how would you all summarise the current state of water quality in HVAC systems in the UK? You know, how do we fare? What would our report card, you know, if we were all at the School of Water Quality, what would it look like? I don't know who wants to go first, Gordon.
I'll take a jump in there first. I think we can do a lot better. It would be the answer to that. I think some of the evidence that we've had, both anecdotally and from research papers that have been carried out, in particular with regards to the heat network marketplace, water quality has been a fundamental issue of system compromised efficiency. And that will lead to difficulties in uptake of such systems as we try and develop the improved status of our carbon reduction policy throughout the UK. If we start to have residential properties not getting the heat efficiently and effectively into their spaces, as was initially intended by design, then rightly so, that's going to be a black spot on that copybook. So we need to do better. We need to make everybody aware of what is involved in that process, because it's actually not that difficult. And that would probably be what I would say so far on UK water quality effectively in closed sealed systems.
So would you generally say that the water going into the systems is of poor quality, or is it okay in general?
Well, water quality throughout the UK is not consistent, and we know that from DEFRA, and we know that from the reservoirs that are supplied around the country on the district mains, and also there's water that comes off a borehole main. So everybody needs to be very very observant about what that water quality is as they're feeding it into the system, and at what pressure that comes from. But I think that's generally well known in the local areas where we're building our buildings. I think that is one aspect of it. The other aspects are more the mechanical aspects of, you know, commissioning the systems correctly, pressurizing the systems correctly, using appropriate devices that adopt and will protect the system. But also, as was mentioned earlier on by Chris, understanding the metallurgy within the systems, and indeed, as somebody was mentioning earlier on in one of the presentations, the use of polymer in the system as well can often be seen as a substitute to get away from corrosion. But exponentially, the components, the ferrous materials that are in the system, will exponentially corrode at a far greater rate if you've got a lot of polymer system pipework in your system. So that is not well known, but it needs to be stated to anybody that's doing design and installation of systems.
Yeah, well, it's interesting. All this stuff you are adding into the water, it's actually driving the components to more exotic material, and that shouldn't be there. But you can very easily check the quality of the water. Have a look in the heat exchanger, because there you catch everything. Yeah,
and I'm interested because we've got quite a good spectrum here of manufacturers, different components within the system, heat generator, distribution as well. What are the issues you guys are seeing? I mean, I say that from a SWEP perspective, I know, but just from an open and for the audience, I'd be interested, what are the problems you all see? What are the things that are causing issues?
So Adam, if I could jump in there. I mean, we from Wiesmann are obviously supplying a wide range of heat generators into the marketplace, from residential to commercial, gas boilers, oil boilers, heat pumps, CHP technologies, etc. So it's a wide range. And interestingly, I think going back to the initial question from you, is that I think we find that the understanding of water treatment is probably not there in the marketplace. I think in the domestic sector, water treatment has been linked to predominantly filtration systems because of old heating systems. and also using inhibitors or chemical systems. In a commercial world, I think the knowledge of water treatment and water quality system is a bit of a hit and miss. Some people are very good and they're doing the right things. But from the heat generator point of view, I would like to say that the quality of the heating water in terms of the filled water and what the people are doing with a sealed heating system is the most important part. And the core problem from our end on the commercial side of it is predominantly lime scale hard water areas, because heat generators in lime scale are a killer of heat exchangers, because the lime scale is settling on hot surfaces, and that will then lead to cracking of metals, leakages, and so on downstream of the site. But there's lots of other areas there which are part of the quality system. Dirt in the system, open systems converted to sealed systems. What have we done with that one? And especially in areas where we are supplying heating systems in old buildings. These old buildings are very leaky pipeworks. If you look at the Royal Opera House in London or whatever large buildings, people don't have the money, the time to go through the pipeworks to check whether they're leak-free. They're putting pressurization systems in their plant room. Nobody monitors water fill level over a week or a month. The heating system will be replenished probably once in a week, once in a month. Fresh water being injected into the heating system, and then they're wondering why their systems and equipment is failing. And I think these are fundamental things, and I've been told numerous of times that applying other systems or continental approaches doesn't work in the UK, because the approach is different. And but for me, water quality is the same, whether it's in Spain, France, Germany, or in the UK. It's always the same. It's just what we're going to do with that and how we're analyzing it. And I think we will come at the end to the conclusion of this. Yes.
Yeah.
Just on that, Adam, I couldn't agree more with Christian there. I mean, the water we drink around the world when we go on holiday might have slight variants about the tap. You might buy bottled water from the shop, whatever you want to do with it. You might like it in the fridge, you might like it in room temperature. We all drink the same water on this planet, but we seem unable to have the acceptance of some of the guidance that comes from Northern European marketplaces where you guys are selling your equipment, without some of the prevalence of issues that we've had in the United Kingdom. So something is inherently not correct in the United Kingdom. And as we look at systems and look intently at systems, just to question and contribute on Christian's side of things, a lot of the scale issues that are in heat exchangers, i.e. the warmest part of the system, is where you're going to have scale precipitate itself. So it's always going to be on the boiler surface wall. It's always going to be on the flow pipework from the heat the equipment. It's constituted by the volume of water that you're putting in. Christian mentioned it again. The pressurization equipment, if we're continually putting fresh water into a system from a hard water area, of course you'll have a scale problem. But one of the things that's in VDI 2035, which is a German engineering standard, is we should not replenish a closed sealed system twice after first fill in the lifetime of a system. Now, I'm witnessing systems that are sometimes doing that in the first 4, 5, 6, 7 weeks of a system.
Yeah.
So if you were in a hard water area, no wonder you would have scaling inside your heat exchangers or your plate heat exchangers or your boiler surface wall. So it's all about replenishing water. Automatic pressurization equipment, advanced automatic pressurization equipment will only put something like 50 litres as the default, or 100 litres as the default, but you can adjust that so that it can just put in 20 litres if you have the security of the system at heart and at the key principles to your installation procedures. But if you're not bothered, then do what you want. Just leave it as the default. And it kind of begs the question, do you truly understand what the equipment is doing? But some of the equipment that we have will go to error if it's putting too much water in. And yet we get called, your equipment's faulty. No, it's not. It's actually saying it's not happy putting that amount of water into your system.
Yeah.
So we should not be embracing this fragrant replenishing of water into our systems, because anywhere in the world, as Christian mentioned, a cubic meter of water has 23 litres of entrained air in solution at ambient and atmospheric. 10 litres of that is oxygen. So for every cubic metre of water that you're putting 10 litres, think of it, 10 litre bottles of Coca-Cola, Pepsi-Cola, whatever, into your system every time you're doing that water. Think about that the next time.
Because I was, sorry, Anthony, I was quite surprised to hear from you, Christian, that lime scale is an issue in the primary side of the boilers, but you're saying it's this constant replenishment of fresh water, so it's almost like a freshwater station, you know, and this is causing you issues.
Yeah, I mean, Adam, with lime scales, and that's what people misunderstanding. It's the same criteria or statistical information that Gordon uses. If you have a very hard water area, which you have on the east side in the London area, south of UK, there can be up to 300 milligrams, 400 milligrams per cubic meter of water of lime scale, dissolved lime scale in the water. And when the lime scale is settling on hot surfaces, you know, and you have got 1,000 liter in the plant room or more, all goes through the heat exchanger. You get this lime scale starting to settling down on the tubes and everything on the inside. That will build up millimeter by millimeter a layer of lime scale inside the pipework. And what it will do to the heat exchanger is, and it will also plate heat exchangers if they're affected by that, then obviously you get a thermal stress developing on the corners, because obviously the material can't expand anymore. There's the heat transfer gets reduced, and therefore you get stresses on local stresses, and then eventually the material gives way, and that's where you get the leaks. So that's one part of it. But of course, lime scale is just one part of water quality of water. Oxygen level, as Gordon said, is the other part. And if you constantly replenishing the water in the heating system, oxygen is one of the major reasons for corrosion. If you remove oxygen in your heating system, closed loop heating system, your corrosion will disappear. And people are surprised how quickly oxygen level actually depletes once you fill the system. It happens within a couple of days.
And I think that's where we've, as a company, have fallen victim of some of the processes that have been taking place throughout the UK, because one of our pipework systems is made from carbon steel or a mild steel type system, and you introduce oxygen to it constantly, and it is one of the materials that will suffer most quickly. And so it will be quite evidenced quite quickly within the commissioning cycle or early days of a system that something has happened within the system that's introducing oxygen at a regular interval. Either it's been drained down and refilled a couple of times, which Gordon's just alluded to, that shouldn't really happen. Or something has happened within the system, be that an introduction of a chemical basis, which, because systems do get drained out and refilled, it might not have been done in exactly the same way as before, so the system dynamics have changed.
Yeah, I think it's fair to say, I mean, you know, carbon steel has had a bit of a bad reputation over the last sort of couple of years because of obviously what's perceived as corrosion issues. But again, carbon steel has been used as a pipework material for many decades, and we've got lots of examples where, if installed correctly, it will perform with no issue whatsoever. We've also seen that historically, you know, we would have more traditional thick wall tubes being used, but obviously with innovation and jointing technologies, we've seen sort of thin wall products come to the market, and they can work quite well. But again, there does appear to be a lack of understanding of how best to install and commission those types of products. But the other thing which I think is also becoming more noticeable is building services systems these days seem to be more mixed systems, mixed metal systems. So we're aware we're people have had some sort of corrosion issue, and rather than trying to investigate what's caused it, the assumption's made that it's something to do with the pipework, and we'll take that bit out and we'll basically put a new piece in, or we'll put an alternative material in. So we've seen a lot more people move to the likes of stainless, with the perception that that's more corrosion resistant. Yes, it is. However, it does cause a lot more interaction with other dissimilar materials. And actually, when you look at stainless, it's a good material, but actually it provides corrosion protection because of oxide layer on its surface. So it needs oxygen, where most other systems don't want the oxygen. So you've got this conflict between an open system and a closed system. And even if you have a closed system, 9 times out of 10, when we actually inspect it, we find out that there's a leak or there's something which is causing a problem, and it's never fully closed, and people are not really monitoring that. So corrosion then becomes more of an issue. And then again, as we've just discussed, when people start doing repairs, again, normally it involves basically a sort of mini commissioning in a localized area, which adds more fresh water and more oxygen into the system, and you end up just pushing the corrosion reaction further off down the pipework.
Yeah.
That's interesting.
One of the comments made earlier on in one of the presentations was that the insurance marketplace is recognising that £1.8 million per day is the insurance losses that are being incurred with regards to the escape of water on construction sites, both domestically and commercially. Now, some of them are drainage, as I understand it, and civil escape of water. But it would be very interesting to see how much is actually being paid by the insurance companies with regards to, pipework system failure within M&E services, effectively, and not just water ingress from a plumbing system or a drain back, sewage water coming back up, or flooding on a site, or penetration of roof structures, or what have you. Because it's only then when we get better data and using data in the right way that we'll make better judgments and we'll make better decisions. But even, the fact that we've got 3 key European manufacturers on this round table with a similar story to tell and some issues to tell, should take cognizance to everybody in the marketplace that we have to address some of these issues, and we have to have better accountability for remediation processes, and indeed installation processes. Because as Christian says, the water's the same the world over. Why do we have a separation of guidance? SIBS and CP1 with regards to heat networks deserve great credit for the first time really truly embracing VDI 2035 and the German engineering standard, and the other standards which are very common aligned to the process that can be adopted. But you need to understand that process, because it is quite disparate from what we've historically been doing.
Yeah. You talked, Gordon, you mentioned VDI 2035, and I know most of us here have had some experience with European standards, either through working for a European-based company or actually working there. A question to all of you, how do the UK standards and approaches compare with what's happening in Europe? Let's say, for example, in Germany, Christian, is there many problems with scale as you have here in the UK?
Yes. So again, I think we need to look at the market from the residential to commercial side of it. So let's focus on the commercial side a bit. So the hard water area in Germany, for example, they've got lots of hard water in parts of Germany as well. So therefore, lime scale is a big issue for heating technology and for the industry. And yes, there are issues with quality systems as well that they're not adhering to, predominantly because if the system is already a few years old, people do forget to look after it, right? And then the water treatment is not there, or they have replaced the fill water several times and then forgotten to treat the water. So the issues are there. However, lime scale as an issue is not really a topic in the UK. That's my own personal experience. It's not a topic. Nobody checks water hardness. When you ask a water company to do a water sample test in your heating system, you will struggle to find water hardness on the test sheet sometimes. You will find pH value is not on there. They give you what a water company is they're bothered about. They're looking after contaminated materials in there, like iron or chrome or whatever other stuff in the water which is bothering them. Lime scale doesn't bother a water company because they like it sometimes, you know. But I think the water hardness is not really major topic. The major topic, in my experience, is people dealing with existing heating systems. They're old. They've been converted from an open vented system to a sealed system sometimes, or they're completely leaky, and they are full with debris, corrosion debris, because of the oxygen side of it. That's part of it. And that was also the history or the legacy of the domestic market. If we move into the domestic market, it's the same thing. The majority of heating systems 20 years ago, 30 years ago, were open vented systems. And then over the last 20 years, we've moved to more and more sealed systems. But the approach of how to deal with a heating system in the residential market is still the same. And what people are recommending, if they have dirt in the system, is adding filters to it, you know, and to mask a problem sometimes. I find it absolutely astounding sometimes if it's coming to a new build system and the installer fits a flow heating system. The commercial world as well. Everything is plastic. All plastic pipes. And then they're loading up the system with filters, chemicals, and everything. And you wonder sometimes, what are they expecting to happen with plastic? Yeah, there's no corrosion happening with plastic.
There isn't, Christian, but remember that exponentially the ferrous materials, so all of the valves are ferrous. Most of the valves are ferrous. The radiators are ferrous. The boiler might not be. It might have a stainless steel heat exchanger, but it might have an aluminium heat exchanger. And if your barrier plastic, if it's got a very good barrier, then the permeation through that plastic is considerably less. But it's the surface area. Remember, that oxygen content needs to be consumed by something. If it's not getting consumed by the plastic, it exponentially will be consumed by the ferrous material that remains in the system. Now, to my knowledge, the building services industry has not moved across to using stainless steel gate valves or gunmetal gate valves, because there's a reason for that. They're quite expensive. So they're not going to use that stuff, but they'll start to question when these valves start to fail, when there's a mass adoption of polymer through the process. So, you know, this disparate belief that carbon steel is at fault here, nothing could be further from the truth. What is at fault is the ability for us to deal with the mechanical hydraulics of these closed sealed systems, regardless whether we want to treat or not, because that's a different subject and a different topic for another day. But we must make sure the mechanics of pressurization, of correct positioning of the expansion vessels, of correct adoption of a pressurization equipment, of correct water fill and correct overpressure at the highest point in the system. If we can manage most of these processes, you'd be really surprised by the results. And with better information from systems with results and trend analysis, we will prove that.
Yeah, and I think it's a similar situation for Geberit. I mean, on the continent, we don't see anywhere near as many internal corrosion problems as we do in the UK. And I think you're right. It's mainly to do with the mechanical elements of the system, but the complete divergence of methodology of how to maintain a system and to look after a system as well. Because we do talk about VDI 2035 and the requirements of pH and salinity and conductivity within our guidelines, and managing those, or being able to manage those mechanically, is what differs between us in the UK and what happens on the continent.
Yeah, I think also in the UK there has been a noticeable change in some product quality as well. I mean, again, you know, we have seen a sort of move away from sort of traditional thick wall carbon steel to thin wall. Obviously, when there's been sort of issues, we've seen people look at moving back or look at cheaper options and say, because technical specifications on pipework are still perhaps maybe referring to old legacy standards, it allows a whole range of different products to be installed. Fortunately, carbon steel tubes may all look the same, but actually they can be manufactured in a variety of different ways and actually behave differently. So that in itself can obviously also be a contribution factor to systems performance and service life performance. And again, I think over the last sort of year or so, it's become more and more noticeable that, again, some of these questions being raised about, what is a system, what's important parameters within a system. Everybody's aware of oxygen and pH. Obviously, water hardness, water conditioning is something which we're talking about today. But the galvanic series, this galvanic reaction, which has always been there, has always taken place, is becoming more and more exaggerated because of the different changes in the volume of base materials now being used within building services. And I think when people are starting to commission or are starting to look at installing these sort of new pipework or mixed metal hybrid pipework systems, they're still applying the old legacy ways of working as if it was, as if nothing had changed. And I think that's also starting to become more and more apparent, that there's a lack of awareness with regards to just how changing hours and changing that dynamic relationship within that pipework system can also accelerate corrosion reactions.
Certainly, the galvanic issue is a point well made, Chris. And it needs to have greater transparency, greater knowledge in the marketplace. Anthony talked about VDI 2035, and we kind of know about it, but I can guarantee you, having done numerous hundreds of presentations to candidates around the country, I'd probably suggest that 95% of the consultant engineers and the engineers and contractors that we see have never heard of VDI 2035. And somebody needs to answer why they haven't. Because there's no reason for them not have been made aware of that process, which by definition says that chemical inhibitors should be used in exceptional circumstances where they're not necessarily required. And going back to the scaling and hardness issue, 40% of the United Kingdom does not have hard water.
But one thing we see in the heat exchanger business, which actually escalates, is the design of the heat exchanger, very often oversized. We try to size it correctly because we measure the turbulence in Reynolds. And if you have an oversized heat exchanger, you get laminar and the scaling is coming up directly. It hangs together for sure.
Absolutely.
On the distribution side.
I think, out of all of this, information is key, knowledge is key, and information leads to better understanding and better judgments in any system. And I think if we can deliver better graphical information and trend analysis on any process, then the whole marketplace will improve upon that. And as of today, there is commercially available systems that are quite easily adopted into these systems that will show you where the good products and projects and systems and clear commissioning processes have been adopted, and it will likewise show you where there's just a wee bit more work to be done. Going back to your report card analogy that we used earlier on, Adam.
Yeah, I think that's important, Gordon, because like I say, normally when we're involved in any sort of investigation, it's normally after the event's happened, where actually if you're monitoring, gives you the opportunity to be able to sort of see those trends or predict if there's something changed in your system. And that might not be corrosion related, it could be pressure drop, it could be something which has an impact on that system, but having that ability to sort of track and see what's happening, you're able to be more proactive rather than just wait until you've got a failure and then it's a case of not really understanding why that's happened and basically spending a lot of money repairing something only for it to possibly happen again.
And Christian made the point earlier on. People would be amazed at how quickly a system that is filled loses the uniform oxygen corrosion process. Unbelievably amazed. It does not last for a long process when you've got a large volume of steel, whether it be EN 10255 or whether it be precision carbon steel of any manufacturer. And you would be surprised. But with that evidence, you will take cognizance of some of the issues that have came across.
I mean, it's this is interesting. And what sort of developments do you think are necessary or even coming up now that can help us in this area of keeping on top of the water quality in the systems? You know, is it even a product? You know, is it more an education, knowledge? You know, how do you see the sort of future developing?
Personally speaking, I think it's a combination of both, but I think certainly if you've got a cost-effective product that basically can be introduced to a system which is a fraction of a cost of some of the processes that are being adopted, to allow you that transparency for a wider audience, so actually expand the audience rather than restricting to the audience to a defined group, and widen that and present it in a graphical way that can basically be looked at from the layman and understand where the spikes are coming from and when the spikes occur, and then look at what has changed in the lead up to that spike occurring and what hasn't. Chris mentioned it earlier on. If you've got a substantial pressure drop and a makeup of water, you'll probably have a corrosion explosion, if you like. Now, it won't be detrimental to the system because you'll consume it very quickly, but you know what the correlation is. With the information, you'll make better judgments and you'll basically have greater transparency, and you'll have probably substantially less failures, better resilience, better system efficiency. You're going to have a happier client.
And just going back to the issue with water being topped up in systems far too frequently, you know, that there's obviously a leak somewhere. Does anyone here any experience of where the hell's this leak coming from? Are there any problem areas? You know, what's the cause of that?
It's absorbed in the building somewhere.
Yeah.
Could be everywhere.
Could be
anywhere. Yeah.
Expansion vessel could be broken and it blows over through the safety valve.
PRVs, yeah.
It's would be different reasons for this. As I said, if you're looking in very old installations, old hospitals, old buildings in big cities,
old radiators.
Old radiators, nobody will find it, the leaks. If you have a big building there, they're just, you know, I think it's the nature of today's world. You know, people don't want to spend much money when they have to renew energy or the plant room with a new boiler because it's broken down. And if the contractor says, well, I need to check your heating system, then that costs a lot of money to go through it. So what do they do these days? They're setting a new demarcation line in the plant room, fitting a plate heat exchanger in there, which is great for SWEP, immediately. But they're fitting a plate heat exchanger in the plant room and the contractor says, well, this is my responsibility. I'm putting your new heat generator in there with the plate heat exchanger. If the plate heat exchanger gets blocked up or not working, then it's a problem with the operator, but it doesn't affect the boiler. And is it the right approach? It's a approach which helps the contractor because then they can set a line of responsibility. But on the other hand, it just masks an issue. It's an underlying problem to come. And in the end, if the system fails and there's no heat being provided to the heating system, then they will contact the company which name is written on the product. And then we are back to square one. And then we're going out there and so on and so on. So it is a very difficult one. In my opinion, Adam, is in terms of development, I think there is a great need for further education of water treatment. And just because all the standards, all the European standards, they all do talk the same thing. They're talking about physics. And to understand those physical reactions and situations in the heating system needs to be understood. And then the contractor, the installer is then able to provide the right solution for that particular system. There is no things. And unfortunately, the standards we've got, there's so many standards in there. You've shown it on your presentation. Nobody knows really where to look at. There's no real guidelines. And I have tried.
If anything, there's too much information, isn't there? If someone's looking, they get hit with such a wall of data and information. It's very.
But you can make it simple.
Some of the questions
you can make it simple, absolutely.
You can make it simple. If you look at the heat exchanger, you're monitoring the pressure drop over the heat exchanger, and then you can check the conditions for the present installation. So that is one way to do it, quite simple.
Yeah.
How is my system doing? Check the pressure drop over the heat exchanger and compare to the design data. That is a good start.
I'm pleased this has come up because one of the questions we've got is somebody's interested in what's the difference between all of the different water quality standards. Has there been a consideration to collate
how many hours do we have?
Yes, I mean, to be honest, the table of Northern European guidance that you put up is very much aligned off of VDI 2035, very similar. The Danish water quality standard, or water conditioning standard, and water quality and water conditioning are different to water treatment. And I think that's very important. Water conditioning, when required, go back to what I said. In Scotland, our water quality is that good, we stick it in our whiskey and drink it neat. We don't drink our whiskey neat, that's a bit dangerous, but you put it in our whiskey and you drink it. So it is that good, we can put it in our whiskey, because we kind of pride ourselves with our whiskey. We could put that straight into heating systems and you would be surprised at the evidence and the results that we get from that process. And that counts for a lot of the west coast of the United Kingdom, all the way down the west coast of the United Kingdom. So dependent upon, obviously we do have the issues of hard water that we've discussed earlier on, but water conditioning rather than water treatment is probably something we want to advise people about. And also the fact that the United Kingdom guidance has been recently revised. There's been a lot of work by possibly it could be enhanced by a wider input to that body of work, but it's effectively done a lot of work and it has made some significant inroads in the process. And even this weekend, BG50 was released by BISRIA just at the weekend. So and there is some really good quality items in there, which is worth an investment in a process to adapt. But these were changed in 2012, 2013, and they've been changed again. So there's a lot to be, for those in that sector, there is an awareness that things are changing. But if you can't measure it, you'll never improve it. So you need to systematically measure that process, whether it be in manual trend analysis or whether it be in a movement towards an electronic analysis and a representation of that. And then we've got a real job to put case studies and put evidence in front of the marketplace that really makes a compelling case for adoption of that process.
I think us as manufacturers as well, both Chris and myself work on the BMTFA. Part of our interest is obviously how materials interact with each other. So part of the work that we're hoping to do next year is to look at these commissioning / water management situations to see how our products, how piping systems interact with each other, because we are seeing more and more mixed hybrid systems, particularly with plastics and different metals, and obviously with the different materials that are used in heat exchangers and boilers these days. Knowing what can happen with the interactions with the materials, that's something that, as British Metals tube and fittings we would like to at least help initiate that education as well.
That's good. Yeah,
I'd embrace that process.
Another one of the questions that's come up is that somebody's talking about plumbers not being recognised as skilled engineers, despite the fact that water systems, whether it's HVAC or sanitary potable water, are very complex, very important, and changes and maybe even at the initial design stage are done by people that don't understand, what's happening or what the effects are. So I think that really alludes to what has come up in this discussion, is that, there's these different metals, different materials being used, and nobody's really taking care or paying attention to what's going to be the impact of that on the wider system.
Yeah,
it's
but
quite
it's not
valid,
just
because
a plumber.
obviously
It
we're all
could
aware
also
that
be the designer that has not designed in a filter or a strainer, for example, to protect the equipment. So it's come from that side as well.
One of the things which is quite noticeable in building services over the last sort of couple of years is there is a sort of a growing skills gap. A lot of people with that knowledge and expertise have retired or left the industry.
Yeah.
Building services is an industry which remains hidden. It's not something which people automatically say, what do you want to do when you grow up? So I want to go into building services. It's like the forgotten industry, yet it's so critical to everything which you see around. but it's very noticeable that because there's that skills gap, and we are trying to attract new people into the market, that there is that lack of awareness, and you see it on some projects where big projects are subcontracted out, and then you see installers who are basically very aware of what they're doing and do things properly, and then you see other parts of the project maybe being done by people who is not as experienced or on fully aware of all the other issues, and then when they try and connect it all together, everyone's wondering why is something going wrong. So again, awareness, training, and also proper guidance for people to refer to if there is a need to try to seek clarification. And again, as Gordon's mentioned, and Anthony's also talked about this, being able to understand what's actually happening inside the system. Once it's commissioned, it's not a case of walking away from it. It's about really monitoring that to ensure that anything which goes wrong, with either design related or installation related or just general performance related, can be detected and understood, so that the right informed decisions can be made to make sure that A, it's fixed, and B, it doesn't happen again.
Just on that point, just very briefly, because I know we're completely out of time. The sampling water 2 days after it's been removed from the system is not terribly reliable. I know that I've sat in contractual meetings when they've said, "Oh, we've measured oxygen back at the lab." Completely waste of time. It's at a different pressure, it's at a different temperature, and it's different environmental condition. Complete waste of time. The oxygen is consumed the minute you take it out of the system. So if you're measuring oxygen, it must be in the system. It's the only way to look at that process. And other, pH will adjust if it's away from the system for any prolonged period of time. So if you are doing manual testing of a sample of water, it must be instantaneous as it comes out of the system as best you possibly can. And in some other ways, you need to neutralize the process to get an accurate recording of pH. So, better knowledge, as Chris said, of that measuring process needs to be adopted, and consistency of delivery as well. Because you can, if you are going down that sampling process, you need to make sure that everybody's tabulating and formulating their evidence in exactly the same manner, so that you can trend analyze it across the lifetime of the system.
Yeah.
I think,
and when systems are monitored and chemically adjusted, shall we say, for pH levels and so on, I think it's also important, and I've had experience of this where it's caused an issue with our products, is that they understand what's in the system. If they're not aware that there's some copper in the brazed heat exchanger and they're adjusting pH levels for everything being steel, then this is causing a problem for the copper and it causes a failure in the product. So even when everything is done that way, without just that basic knowledge of what's in there is just so important.
I think sometimes everybody thinks that stainless steel is absolutely bulletproof, but if your nitrate levels are so high, so you'll start to get issues with stainless steel.
Pitting, corrosion,
We've had it with freshwater stations, in Germany. It's
I don't think you're ever going to resolve it in 45 minutes, but I very much appreciate the opportunity to come and join you and have the conversation. But I think we've probably got the gruesome
we've run over.
Reformed and come back into the lines. But
So, I mean, some closing comments. I mean, from my side, I've been in the industry a while, and water quality has always been an issue I've heard of and an experience. But I have to admit, doing this roundtable with you gentlemen, has been a great experience. It's been a real eye opener. It's kind of blown my mind a little bit, because you think you know where the issues might be, but they're actually quite wide ranging, and they're very wide ranging, in fact. And I don't think it won't be hard for us to fix it, but it's easy for us just to keep going and for the problems to keep happening. So I think the theme of building back, better carbon reductions, efficiency, really we've got some work to do, haven't we?
Yeah, I would just say that some of the mechanical issues are actually staring us right in our face. Yeah. And it's just a matter of basically resolving them, and the results will be a damn sight better than they are at the moment.
Yeah,
and they need to be as we escalate the green energy fund is growing exponentially to make sure that we make these new carbon reduction trends coming into line and going back to your water's the lifeblood of these processes, and the majority of them, we need to make that quality better.
Yeah, we could give everyone a free heat pump, but it wouldn't matter for the carbon reduction if they're not installed correctly, if they're breaking, if you think of all the carbon involved in having to repair things and remanufacture. So it's of absolutely crucial importance, and it's at every level, isn't it? It's the design, material selection, installation, the procurement process, who's installing, how many people are installing, who's commissioning, who's looking after it. It's at every level, isn't it, of building services where we could make a difference and improve it.
Absolutely. And I think finally from my side, I think we need to allow installers, contractors also to adapt the water treatment regime they want to put in place, which is maybe not in line with the British standards or so. Yeah, like VDI 2035, as we discussed earlier on. There are some local documentations there which are discouraging the installer to lean on to European standards. And I think that, again, doesn't help. There is now a growing popularity of people using the VDI 2035 methodology, let's call it like this, which is good, and it's very technical, and it gets to the point to solve the problem. And I think we need to allow those people to use those methodologies if they want to apply the right solution for their customers.
Yeah.
And regardless of what methodology you adopt, try and monitor it, because it will tell you what's happening with regards to any form of remediation or any adjustment or any substitution of a contractor, whether it be an FM contractor, maintenance contractor that comes into the process. And if they are impacting on that and not looking after the same trend process that's happened years before, what is different? What's been adopted differently?
Yeah.
And I think, from all of our points of view, where and the companies that we work for, we are trying to take the lead on this. And I'm sure we would all say we're all more than happy to help any installers, contractors, specifiers, with projects, share the knowledge, the, experiences that we've had that's been built up over many, many years to make the systems more efficient, more resilient, and less prone to problems.
That's why we developed this one, Adam.
Yes.
Recommendation for water quality. To help support, even if we are in the end of the food chain.
Yeah, absolutely. Well, we're 2 minutes off time. I thought the finish time was 15:15, but I think it's 30:30. So we've done spectacularly well. Thanks to everyone that's listening.
Thanks to everyone listening.
I can just see, or listening and viewing, I can just see a 26 figure there. So that's good.
I was up in 43.
Yeah, and big thanks to all you guys for all the preparation, all the work we've done, for turning up today and giving us your valuable time. I and SWEP and hopefully all the listeners really appreciate it.
Not at all. Thanks very much for the opportunity.
Thanks for
sharing.
sharing.
Enjoy the rest of the
Bye-bye.
Take care.